Hello everyone, this is Masanori Hirano. I'm a PhD student at the University of Tokyo. My presentation title is Concept and Practice of Artificial Market Data Mining Platform. At first, I'll explain the efficient market hypothesis. As many of you know, this is a well-known principle, but it is not proven officially. This art illustrates efficient market hypothesis. And then the man in the art say, why didn't they pick it up? They must believe in the efficient market hypothesis. It means that everyone think money is not on the sidewalk because other people have already took it if it is worth. In the context of financial market, the efficient market hypothesis means there is no beneficial information because if they exist, someone has already taken it. You know, there are some types of level of this hypothesis, such as weak hypothesis, semi-strong, strong. However, in this study, we will not distinguish them. Because the efficient market hypothesis, Adam Smith also proposed the invisible hand. According to him, even if investors act selfishly, they will eventually be guided by the invisible hand to make the economic efficient and grow. Those assumptions, I mean the efficient market hypothesis and the invisible hand, seem slightly strong assumption, but now widely spreaded. On the contrary, difficultness of financial prediction task is frequently argued. And in many studies, the prediction performance are frequently compared with chance ratio. I also understand that those difficulties. However, many studies say the difficulty comes from uncertainty or efficient market hypothesis. Of course, I think it is partial too. For example, it is not clear how to express the uncertainty, and it is also unclear where the uncertainty comes from. Moreover, because of efficient market hypothesis, each prediction will be not working, and even small prediction is great. It is also true. However, are they quantitated? How big those uncertainty? Or which level of efficient market hypothesis you are assuming? There is those questions. Yes, for addressing those questions, I think explaining them scientifically is necessary, or it is exactly what we should do as academic research. More easier, if we cannot predict, we should reveal why it cannot predict scientifically, or we should reveal what contributes to the difficultness. Moreover, we want to make it clear. First is what is truly unpredictable, or what is current technical problem. So my blueprint for it is like this. For example, 40% of unpredictability come from market efficiency, and 20% of unpredictability come from trading rule, and 20% of unpredictability come from technical problem, and then the rest of us come from unexpected outsiders. So our blueprint is like this. For this purpose, we came up with the usage of artificial market simulations. The advantage of artificial market simulation are explained in this slide. Firstly, everything under control in artificial market simulation. It means that we can enable competitive experiment. Moreover, the combination of artificial market simulation and data mining is also good because the predictive potential of data mining can be examined in the completely under-controlled market. In this study, we propose a scheme for this, and we also demonstrate the potential of usage of the combination between the financial market simulation and data mining. However, there are many things we cannot show in this study. So For example, the results obtained in this study are still very limited, and there are many things we should address in the future work. This is a concept picture of artificial market data mining platform. Basically, this is a combination of artificial market simulation and data mining. It is a kind of digital twin of financial market. In this concept, data mining methods are applied under the artificial market simulation. Thus, we can control all the situation of market. By controlling the market situation at all, we correctly compare the data mining performance. This is just a concept, so the different type of experiment also can be carried in this platform. But we assume that the traders publish their order in financial market like this, and then those orders are processed in the artificial market. So then aggregating those orders, index or charts or others are generated. Using those data mining methods are carried and check the performance. But the flow is not limited to it. As a validation of our concept, we made a practical example. This example is built to reveal which factor of financial market is important for data mining. In this example case, as artificial market financial market simulations, we employ the simulation of previous work. That is modeling the stylized trade based on fundamental and chart and noise factors. In this market, we assume only one asset handled by continuous double auction market mechanism. Contrary, as a data mining method and prediction task, we employ the attention or CNN and or LSTM-based deep learning model for price movement prediction task, which consists of three classes: up and stay and down. So next, I'll explain about the details of the stylized trader. In the stylized trader agents, as I mentioned in the previous slide, the trader decides their orders based on fundamentals, charts, and noise, and detailed. Those are the details. And then in this simulation, the weight for them, WF, WC, WN, is very important. Thus, we fix the weight for noise as an anchor, and then change the weight for fundamental and the chart. Moreover, instead of noise weight, we also change the scale of noise. It means sigma n. In addition to those three parameters, we also change in the number of agents existing in the simulations. It means the number of stylized trader agents. So here is the detail of data mining model. As input features, we employ the 32 historical order data in simulations and predicts the next price movement, up or stay or down, in the next 100 ticks. Same as the usual procedure, we split the data into train and validate and test. And in the other architecture of deep learning model, we employ the CNN-based deep learning model and LSTM-based deep learning model and attention-based deep learning model. So as evaluation metrics, we employ the accuracy, macro FM, and micro FM, and weighted FM. As an experiment, we change the parameter in simulation as I mentioned earlier, then observe how performance of data mining method will change. Through evaluation of performance matrix distributions, we analyze which of those parameters are highly contribute to the data mining prediction performances. Here is all the result. In each figures, horizontal axis means the evaluation matrix, and then vertical axis is probabilities. So each vertical column is representing each performance metric. In this case, accuracy, macro F1, micro F1, and weighted F1. And then the horizontal wall represents the result of decomposition of each parameters. It means that the first row means that the distribution sorted by the each agent number of agent, and the second one is based on the fundamental weight. Third one is the child weight, and the fourth one is noise scale. So in this, so for example, on the lower left figure, I mean this one is a plotted accuracy distribution, and each color corresponding to the accuracy distribution, which is divided by each noise scale. So according to these figures, it is very clear that the noise scale is highly important to prediction performance distribution. So in this figure, we only showed the attention-based model result, but other models result are also almost the same. According to the result, we can obtain some beneficial discussion on suggestions. Firstly, according to our result, noise scale has the biggest effect. So our result shows that clear decomposition of performance distribution are carried by noise scale. And then this result means bigger noise causes no price directions, and it makes the prediction more difficult. It seems very natural result. Also, it seems worth nothing, but this natural suggestion was delivered by our concept is very important things. This means that our concept is highly potential to reveal the important features of financial market. Of course, our practice is still very limited. For example, we only used 4 factors: weight for fundamental, weight for chart, and noise scale, and the number of agents. However, it is more extended. So as a future work, we try more factors and wider application of our concept. But I believe our concept is just a concept, and if many studies are to try applying our concept to many tasks, it can reveal many things in financial market. Finally, this is the last slide, and we conclude our presentation with this slide. As a conclusion, we propose a concept of an artificial market data mining platform. We also demonstrated practice of our concept, and we successfully showed the evaluation of data mining method in artificial market and factor decomposition for performance indexes. So our experiment showed the potential of our proposed concept. As a future work, wider application or more practical analysis or more cases demonstrating the potential of our concept should be addressed. This is the end of our presentation. Thank you for listening.